All right, greetings everyone. Welcome to the video on the prereq material for section 3.8. I'm going to talk about isolating or solving for variables. And we've done a little bit of this already this quarter, but just doing some reminders and maybe doing it in some different ways. So let's first start with this first one here, where it says 35 equals 9x squared minus 1. We're asked to solve for x. So write that out here. And we know that if we're going to solve for x there, we need to isolate that x term. So we can do that by adding 1 to both sides. So this would become 9x squared equals 35 plus 1 is 36. Then divide by 9 on both sides. Since the 9 is being multiplied by the x squared, so we'd have x squared equals 36 divided by 9 is 4. And then to finish solving for x here, we need to undo the squared term, right? So do the inverse of squaring something, which is square rooting it. Do the square root here. Now normally, when we take a square root, recall we get 2 different answers, and we show that by a plus or minus. So here we would end up with x equals plus or minus square root of 4, or just plus or minus 2 would be our answer there. Okay, so that looks like that. So doing some inverses of power functions there. All right, let's look at the third one now. So this v equals 1 plus 4th root of t minus 5. We're told to solve for t. So we'll start this one, just like we did the last one, with the goal to isolate the t. Right, and I think we can agree that for this, well, first of all, the t is here, and notice we have a variable for v, so we're going to have to end up with a v in our answer. So we're going to start here by just taking care of the constant being added by itself out there, so we'll subtract 1 from both sides. Notice here the v and the minus 1 are not like terms, so we cannot combine them, so this will stay as v minus 1 equals, and on the right hand side we have the 4th root of t minus 5. And then to undo, well, at this case you might, or at this point you might be tempted to try to add 5 to both sides, but we cannot do that yet, because the 5, both the 5 and the t are underneath the root there. Okay, so we can't just move the 5 outside of the root. So instead what we'll do is take that 4th root and do the inverse of that, which is to raise it to the 4th power. And we'll do the same thing with the v minus 1 here. So what we end up with then is v minus 1 to the 4th equals, over here the 4th root and the 4th power cancel out, so we have t minus 5. And then we add 5 to both sides. And when we do that, we end up with t equals v minus 1 to the 4th plus 5. Okay, so that one's a little different than the last one we did, in that this time we had to raise something to a power to undo a root. Okay, so we're using, in general here, we're using lots of inverse operations. All right, let's look at the last one now. So there we have w equals 3 over r minus 3, and we need to solve for r. Okay, so to do that, okay, we'll set this up as w equals 3 over r minus 3. Now here, notice that the r, the variable we're solving for, actually appears down here in the denominator, right? So in order to solve for it, we need to get it out of the denominator, which means we need to get this whole term that's in the denominator here, this r minus 3, out of the denominator. So we'll get that by multiplying by r minus 3 on both sides of the equal sign. So when we do that, the r minus 3's here on the right hand side cancel, and we just have the 3 equals, And then we have an r minus 3 times w. And then at this point, we could divide by w on both sides, but I'm actually going to distribute the w into the parentheses here. So when we do that, we'll end up with w times r minus 3w. So we get from just distributing the w in there. And then we're trying to isolate the r, which means we need to isolate the term with the r, which means we need to add 3w, both sides of the equal sign. These will cancel. And now we have WR equals 3 plus 3W. And then to solve for R, just divide by W on both sides. Cancels out the R's here on the left-hand side, so we end up with R equals 3 plus 3W all over W. Okay. So kind of a couple of tricky things or tips we want to pick up from that one. So the variable was in the denominator. So we multiplied the term that contained the variable by each side to get it out of the denominator. And then here, we had the w outside the parentheses, we distributed in order to be able to isolate our r value. Okay. All right, that's it for now. Thank you for watching.